Hello everyone, let's take a look at our next problem. A sequence of numbers x1, x2, x3 up to x100 has the property that for every integer k between 1 and 100 inclusive, the number xk is k less than the sum of the other 99 numbers. Given that x50 is equal to m over n, where m and n are relatively prime, find m plus n. Okay, that's an interesting property. I'm not sure exactly where to start here. I mean, we could write down an expression which represents this property. I'm not sure where that will take us. And it's a sequence of numbers. It doesn't say anything about whether they're integers, rational, irrational, although x50, they claim, is a positive rational number. I think what I'm going to start with is just writing down an equation which represents exactly the property that's given here, and then see if playing around and manipulating that equation in any way allows us to figure something out. Maybe what I'll do, maybe what will end up happening is I'll write that equation down for every possible one of the numbers, x1 up to x100, and try and focus in on the equation corresponding to x50 and see if I can, add all the equations together or subtract them all or something like that, and just extract out what x50 has to be equal to. But let's start by just writing down this property in an equation. So this is what this property looks like for an arbitrary value of k. We're told that xk is exactly k less than the sum of the other 99 numbers. So there's the sum of all the numbers other than xk, and we subtract k, and that gives us xk. My first inclination here is maybe to add all of these equations up for all values of k, because then what I'll have here on the left-hand side is just the sum of all the numbers. Here, what will I have? Well, I have 99 times the sum of all the numbers, and then here I just have the sum of the integers from 1 to 100. So this would tell me what the sum of all the numbers is, but not necessarily what any individual number is. Right, so the sum of all the numbers in this sequence with this property is equal to 5050 divided by 98. This is the sum of the first 100 integers. It's kind of a familiar number if you've done this a lot. I'm pretty sure I did this correctly, right? If I had a simple double sum here over every possible index, like if I didn't have this inequality down here, then I would simply have each individual one of these terms would appear 100 times. So this would be 100 times the sum of all the numbers. But each term in here is missing once. So I just subtract each term once, but that's the same as subtracting the entire sum itself. So I end up with 99 times this, and then rearranging this equation gives me what's down here. What happens if I write the expression corresponding to 50? Maybe if I write this equation for x1 and x2, kind of see how x1 and x2 are related to each other. Maybe I'll be, or what I'm thinking of extending this is write this equation for a general value of k, and then write it for k plus 1, and see if I can find the difference between xk plus 1 and xk. But I'll start with x1 and x2. So for x2 and x1, the difference here, this has all the numbers except x2. This has all the numbers except x1. So when I take a difference, all of the numbers cancel, except I don't end up canceling the 1 from here because it doesn't exist here. And we end up sort of over canceling the 2 here because the 2 does not appear here. And then the negative 2 plus 1 is still there. Okay, I'm gonna do this again for a general value of k and k plus 1 and see what I get. Did I make a mistake somewhere earlier? Yeah, this is this should not be 1 and 2. It should be, this should be an x1 minus x2. And so this equation here becomes 2 x2 minus x1 is equal to negative 1. So x2 minus x1 is equal to negative 1 over 2. Good. And so it is just a specific case of this general one here. Okay, so what do I have? I have that xk plus 1 is equal to xk minus 1 over 2. Okay, so this tells me that the difference between any two values in the sequence, the terms are decreasing by a half every time. So xk is equal to x1 minus 1 over 2 times k minus 1, right? So we have an arithmetic sequence, and we also know the sum of all the terms is up here, and so we should be able to figure out any one particular term. Okay, so the sum of all the terms, I'll just write it like this. This is equal to x1 plus x100 divided by 2 times 100. So we have x1 plus x1 minus a half. What I'm trying to do here is I'm trying to solve for x1. There might be a more direct way to do this. We might be able to solve directly for x50 here somehow, but I'll just include this intermediate step. Okay, so that's the sum of all the terms, and we know that this is equal to 50 divided by 98. So I have 101 over 98 is equal to 2 x1 minus 99 over 2. Okay, so this gives us x1, and I believe this is in reduced form, right? The bottom is divisible by 7, but it doesn't look like the numerator is divisible by 7. Let me just check that again quickly. Yeah, the numerator is not divisible by 7. Okay, so I have x1. This tells me that x50 is equal to 1238 divided by 49 minus 49 over 2. Oh, goodness, okay. So I get that x50 is equal to 75 over 98. I don't believe that's reducible in any way. 98 is equal to 2 times 7 times 7. And 75 is equal to 15 times 5. Or, well, of course, it's equal to 3 times 5 times 5. Okay, so, right, this is equal to m over n. So m plus n is 75 plus 98, which is, I'm a little tired. Let's just not take any risks and do this in full. Oh, what am I doing here? What am I doing? Multiplying instead of dividing, or some weird combination. $173. Yeah, I feel pretty confident about this as usual. It's possible I made an arithmetic mistake somewhere. I think the key to this one, of course, was writing down the original property in an equation like this. And then I'm not sure exactly what it was that allowed me to identify right away that summing this up over all values of k would lead to something useful. I mean, I didn't know that this was going to be useful in the end, but even though it turned out to be, it was worth kind of pursuing this anyway. And then the other key to this was writing down the expression for two subsequent values of k so that I could find the difference between two values. I had, at some point working on this problem, I had a suspicion that this was going to be an arithmetic sequence. I wasn't really sure, and I didn't have a great way of arguing that, but we just derived it here based on the property. So that was good. Turns out to be an arithmetic sequence that decreases by a half on each term. I suppose if you think about that, that makes sense, right? Like, you have the sum of 99 numbers. You eliminate one number, but put another one back in, and we know how much that changes by, or at least that the amount that changes by is going to be the difference between the two numbers. Anyway, this is a cool problem. Pretty confident in this final answer here, 173. If I find any errors or if I have more comments on this later, I'll add them in the description. Otherwise, thanks for watching.